Hello, math friends. Today we're going to talk about how we can use equations to solve real-world problems. So one real-world problem we might have is a cell phone company charges a $50 activation fee and $45 per month. We need to write an equation in slope-intercept form to represent the situation. So I might start this out if I'm just not real sure how to get started. I might start with maybe making a little table of, hey, what if I look at how many months, and then I look at my work, what's happening here, so that I can keep track of it, and then I look at my total cost. And I'm thinking that maybe if I do this, the equation will just kind of pop out at me. I'm going to read it again and underline that important information. A cell phone company charges a $50 activation fee and $45 per month. So if I have my phone for 1 month, it's going to be $50 to activate it plus that $45. And that's going to give me a total cost of $95. What if I had it for 2 months? If I had it for 2 months, I'm going to have my $50 I have to pay plus my 45, but I'm going to have to do 45 again, so I could say times 2. If I do that, this is going to give me 90 plus my 50, 140 bucks. I could even jump ahead and say, what if I had it for 10 months? If I had it for 10 months and have my $50 activation fee plus my 45 times my 10 bucks. 45 times 10 is going to give me 450 plus another 5,500 bucks. I'm starting already to see a pattern that might help me be able to write the equation. I'm seeing 50, 50, 50. That seems to be staying the same. So I could say, all right, I'm always having 50. All my pluses are the same. I have my 45. And then it seems like my months, here it's 2, here it's 10, and actually up here I could have just said 1. It's changing, so I probably need a variable there. I could use M for months, that would work. And it looks like the 45 is actually my slope, which makes sense since it's the thing that changes. And that 50 is my y-intercept, which also makes sense because that's the place where I have to start. And so I can say, hey, this expression is equal to my C, my total cost. So cost, I could say, hey, that's going to be C, and M's going to equal my month. So my equation in slope-intercept form then would be, I'm going to write it big and bold, I have my C equals 50, my y-intercept plus 45M. Now I chose to use M and C. You could use X and Y here too, and that would be fine. But there's my equation of my real-world situation in slope-intercept form. Let's take a look at another one. Party Central, party, charges $3 for laser tag and $12 to get in. Which equations represents the total cost of a visit to Party City? I think that should just say equation. Which equation? Sorry there. Represents the total cost of a visit to Party Central. So Party Central charges $3 for laser tag and $12 to get in. So again, I could think about that table and think about, what if I play 1 game of laser tag? If I play 1 game of laser tag, I'm going to have to pay my 12 bucks to get in. Plus, I'm going to have to pay my $3 times my 1 game. And I can figure out my total cost, but I don't even have to because really I'm looking for the pattern here. If I play 2 games, I'm going to have my 12 bucks that I got to pay to get in plus 3 times 2. And if I jump up to, what if you went nutso and you played 10 games of laser tag? You'd be dripping with sweat, that's for sure. And you take your 12 that you got to pay to get in plus 3 times your 30. Okay, I can see my 12 is staying the same, my pluses, my 3, and then there's these things changing, which is the number of games of laser tag. So if I take a look here, it looks like in my choices, they're going to use X and Y for my games of laser tag and my total cost. I'm looking for one that looks like 12 plus 3 times my number of games, X. So if I take a look here, this is saying 12 times X. Well, that's doing 12 times the number of times to get in. That would be kind of crazy, and then just 1 game of laser tag. So that's not going to work. Here, again, they're doing 12 times the number, the admission price, times the number of games of laser tag. That doesn't make any sense. Here they're saying 9 times X. So they're saying it's only going to cost me $9. That doesn't make any sense. It costs $12 to get in. I'm not going to be able to just pay $9. And here I have a match. So I have 12 plus the 3X. The table really can help you get started if you just try to talk about what if I play 1 game, 2 games, 10 games. Look at these sweet places. I want to play laser tag here for sure. I hope you do too, and I hope you can write some equations for some real world situations.